Hello, so today we are doing this problem called minimum window substring. And so the problem says that we get a string S and a string T, and we want to find the minimum window in S that will contain all characters in T. And so we have this as S and this as T, and we want to find the minimum substring in this S that has all these characters. And so we can find, for example, so let's take this here. And so also it says that there is no such window in S. If there is no such window that covers all the characters in T, we should return the empty string. So if there is no window in S that contains the entire all characters in T, then we just need to return an empty string. And they are saying that there will always be one unique minimum window, right? And so let's think about this. So if we take this string here, this is our S, and this is our T. So the first thing we can think of is just doing some brute force solution, right? Just go through all substrings of S and check for each if they contain all characters in T, and if one does, then compare it with the minimum we have so far, and at the end return that minimum. But that would be really expensive, so that would be going to all strings of S, so that's O of n squared of S. O of n squared, such as n is the length of S, multiplied by the length of T, because we are doing that check that it contains all characters of T every time, and so that's really expensive. So we want to improve that. So how can we think about doing this? So this says minimum window substring. So the problem asks us to find the minimum window substring. Again, substring is like, you can think of it as just a contiguous subarray, because if you think of the string as an array, then a substring is just a contiguous subarray, right? And whenever we have a problem that asks us about minimum contiguous subarray, because a window is just a subarray, right? And so we need to find a minimum or a longest, or so whenever we have a minimum is basically window means just shortest, right? That's just what it means. Shortest subarray, right? So whenever we have a problem that says shortest, longest, find some max, find some min, find some sum equal to something, even it can be with some extra conditions, but if the main goal of the problem is this, we need to right away think about using the sliding window technique that is really effective in these kind of problems. And so now we just need to think about applying it to this problem, right? So let's think about this. So for the sliding window technique, we need to find, we use two pointers, right? We use two pointers, one for the left side of the window and one for the right side of the window. But our window may have some extra data that will help us determine what to do, right? And so we need to just find what is the extra data we need that will help us apply this. And so basically usually the sliding window technique, there is some condition that says, basically there is like we have, so let's say this is our sliding window, we have the pointer I, and let's say we moved around and we have some pointer J. So sometimes we move J and other times we move I to make the window shorter, right? To make the window smaller, or to move yeah, basically you get the idea. In some problems we move I and J like at the same time, if it makes sense, but in other problems we keep I in its place but we move J until some condition is met, then we start moving I, right? And so basically for when we want to apply sliding window technique, we need to find the condition of moving I. So when to move I and when to move J. And so what does moving J mean? Moving I means, so moving I means shrinking the window, right? Because if I was here, my window was this entire thing, right? It was this entire thing. If I move I, my window becomes smaller, so it's like this, right? And if I move J, that means I expand my window, I increase its size, so I expand my window. And so what are we looking for? We are looking for a window we are first looking for a window which is a substring that contains all characters in T, right? That contains all characters in T. So what does that mean? That means that we need to keep trying to find that. First, let's just forget about the minimum and then just think about obtaining a substring that contains all characters of T, and keep advancing J as long as we didn't find a window that contains all characters in T. So when to move J is as long as the window doesn't contain, the current window doesn't contain all characters in T. And when do we move I? Now once we have all characters in T, we need to find the minimum window, right? And so in some cases, so for example here, let's say we kept moving until we reached this C here. So does this mean we have all the characters in T, right? But maybe we could make this window smaller. We don't know. So we need to try to make the window smaller by shrinking the window. The only way to make a window smaller is by shrinking the window. If we advance J, we will just make the window bigger, right? So we need to shrink the window in order to find a minimum window substring that contains all characters in T. So we need to shrink this here. And so when to move I, shrink the window when we have a substring, a window that contains all characters in T. Then we move I to find a beta, which is basically means a smaller window, right? Now I'm a little bit tired of writing this window that contains all characters in T and windows that doesn't, so let's just give that a notation. So let's say a window is desirable if it contains all characters in T. And so basically what does this mean? That means that now our conditions become when to move I. So move J when, as long as the window is not desirable, the current window is not desirable, right? And move I so we said move I when, as long as the window is desirable. And while doing that, keep updating min window, because basically we keep updating min window if it's still desirable. That means that it's still a possible solution, and we are looking for the minimum window, so we'll still need to compare it with the minimum window and update that, right? And so now all we have to do is find a clean way to know that a window is desirable or not, and to know that when it's not desirable and when it's desirable, to find the solution, right? So to know if it's desirable, we just need to know if it contains all characters in T. And T can have like duplicate characters. It can have B, C, C, something like this. And at that point, the window needs to contain 2 A's and 2 C's, right? So this hints to us that we need to use a map of character occurrence. So we need to have a map, let's call it occurrences map, that just says in the current window, we have, or maybe let's call it something like, let's call it something more clear. Let's call it need, right? Yeah, let's call this character need, because it just says to us this window needs to have these occurrences of characters, right? And then let's have map of occurrence of character occurrences in T that need to be in window for it to be desirable, right? And so we will initialize this need map here with the occurrences of the characters in T, right? And so what else do we need? We need to know right away when a window is desirable, right? So we can keep a variable called missing that just keeps track of that is initialized to the number of characters in T, and we update and then we update this missing when we find a T character in a window. And also, so basically when we encounter C, we will say, okay, now missing is -1 because now we find 1. We need just to look for 4 more characters. And when we shrink the window, let's say we had A in the window, so the need was just 4. And if we shrink the window, then at that point, this one is no longer in the window. So our missing now increased by 1 because we need to find another A, right? And so basically what this means is that missing +1 if when we shrink the window, and missing -1 when we find a T character at SG, the value of the value we just moved to, right? And yeah, so that's basically all there is to it. And what does this mean? So when do we shrink I now? What is the condition to shrink I? So now, condition to shrink I, to shrink window, which means increment I, is when missing is equal to 0. Because when missing equal to 0, that means that all characters are in T. Because missing equal to 0 is now equivalent to window being desirable, because that means that all characters in T have been found in the window, right? And so now we have this data for our window. So for a sliding window technique, we need to always think about what is the window data that we need to keep track of. And in our case here is just the need map and missing variable, right? And that's all we need. And we know when to move I, we know how to move the window, and we know how to update to find to keep updating in min window to find the right solution. And then at the end we can just return the min window that we have, right? And so now we have our data that we need to solve the problem. So let's just start coding this up. So we need our window data, which is need and missing. And need is we said it's just the map of the character occurrences in T. And in Python we can just say use counter, because let's take this T here, right? And so if we take this as T and we say collections, let me import collections first. So import collections, and we say collections dot counter for T. You can see it says we have 2 A's, we have 2 C's, and we have 1 B. So it just counts for us the occurrences of each character in T. And so we can just use that, right? And so we can just say counter of T. And what is the missing element? So at the start, it's the number of characters in T. So we can just say it's the length of T, right? And now we need to initialize I and J. And we need to have our min windows string, right? Min window. And let's initialize it to this. Or let's say min window start. Let's call it min window start instead. So just keep track of its start index and end index that we can get at the end, and min window end. And let these two starts at 0. And we can, so actually our algorithm ends when G reaches the end here, right? Because at that point no need to do anything. So we need to do, while J is less than the length of S, we keep going. And so the first thing we need to do is we have a character, so we need to update missing when we find the T character in window. And so what does that mean? So that means that missing, so basically if need of the character that we are at, which is sj, if that value is bigger than 0, right? So if the value at this position is bigger than 0, that means we need it for T, right? And so that means we just found a T character in the window, because sg is bigger than 0, that means it's in T. So basically this means that sg is in T. And so that means we need to update missing, because we found a character, so we have one less missing character, right? And then we need to check if we need to shrink, right? So when do we need to shrink? When missing is equal to 0. So if missing is equal to 0, then we need to shrink the window. And so how do we do that? We say we keep shrinking until I starts. If we get to here and the window is still missing is still equal to 0, then we need to advance j, because there is no point in shrinking more. That just doesn't work. The window needs to be like a valid window though. And so we are going to do while I is less than j, and the current start of the window is less than 0. What does this mean? That means that there is a character in si, so we need to do -1 when we find a T character in at si, right? And so if the character is less than 0, then that means that character, since that character is that character is either not in T, or it was in T, but we removed it, right? So one thing I forgot to do is here, when we found a character in T and we used it, we need to decrement, because if we found A, we need to say that now we just need one more A. We don't need 2 anymore. So we need to say need sg -1. And here, when we want to advance from I. That's the goal here, is to shrink the window and advance from I. So we need to say that now that we are moving, so if we were here, if I was here and we moved from I, then what does this mean? That means that this A now we need it now. So before need of A was equal to 0, but if we move, it needs to be equal to 1, because we need to find that A in the new window, right? And so we need to say need si +1. And yeah, that's all there is. So we did this condition here, and now we need to update the window. So we said that move I as long as the window is desirable, and keep updating the min window. So when we moved I as much as we can, now we need to update the min window. So min window now is min window start. If min window start, min window end minus min window start is less or equal to so if j minus I, so this is the size of the new window, and this is the size of the current minimum window. So if this is less, that means we found a better solution. And so at that point we need to say, okay, minimum end and minimum window start become I and j. But we need to be careful of the first case, which is both I and j are equal to 0 at the start. And so we need to just safeguard against that. So by saying not, so that we don't give empty strings as the result, right? And then once we did that, we can just return our minimum window, which is m start until m end. and that's all there is to it. And so you can see here we moved we moved j, and then we checked if the condition to shrink the window is happening, then we shrunk the window, and then we updated the minimum window. Yeah, that's all there is to it. Let's see. Okay, so it's let's just say it's lowercase t. Yeah, I didn't update j, like I didn't increase the value j, so I need to do that, j plus 1. Actually I should do, so mw start, actually it's mw. Okay, so we have an empty string there. So actually, to have at least one character, we need to start j at 1, right? Actually, this is not end. So if for the first window we need to update it, we don't need to, like like say when we are at 1, we need to update so that we have something to start out with. So let's see. Okay, what did we do wrong there? Yep, so I put the wrong values in the wrong order here, so that messed up. The start needs to be I and the end needs to be j. And now we don't have the updated window, right? So let's see, why is that? Yep, so I'm starting here I and j, that's so that's correct actually. Let's see, why is this not working? This is a little bit confusing me. I'll just put it to uppercase and lowercase and see. J minus I, and let's call this I j, so that we know exactly if we are messing this up. And then this becomes I, this becomes j, and so need is collection is the occurrences of the characters in T. This one is the length of T. We start out with, let's just put this, let's initialize just I and enumerate this. So for G, just to make it more clear, S1, and we need to have, what else? Index out of range. So this one, let's call it C. And so SG is C actually, and SI stays as SI. What else? So this here, to be greater than 0, we do -1. Okay. And so, okay, so that seems working. But yeah, the algorithm is still actually the same. We just go through the string, and then if need C is, so basically we apply this. So if the character is in T, then we have one less missing number, and we have one less occurrences needed for that character to occur in the window. And if we reach a condition where we no longer have any missing elements, so basically this means missing equal to 0, then at that point we can just say, we can just keep shrinking the window while we have, while the first character is still less than 0. So basically what we are doing is we keep shrinking the window when we find a T character at Si. So basically we keep try finding a minimum window while we still have we still find characters in T, and then we keep updating the window, and at the end we return the minimum window, and that's all it is that we are doing here. And so this solution passes, and yeah, that's all for now. Yeah. And yeah, just keep in mind this way of finding the minimum window substring, and finding the conditions to move I and j, and then thinking about what data do I need to accomplish this, and thinking about what data structure can help me do that. For example, here we found a map to do that, a map of occurrences. And then after that, you just implement the solution. Yeah. So that's it for now. See you next time. Bye.